Universiti Malaysia Kelantan (UMK) adalah universiti berteraskan keusahawanan. Kami membawa aspirasi kerajaan yang mahukan generasi muda bukan sahaja berpendidikan tinggi tetapi juga berjiwa usahawan. UMK adalah universiti keusahawanan nombor 1 di Malaysia dan bercita-cita menjadi salah satu yang terbaik di dunia menjelang 2030. Ini adalah selaras dengan dasar keusahawanan nasional yang ingin menjadikan Malaysia sebagai negara keusahawanan pada 2030. Menurut visi ini, UMK memastikan keseluruhan universiti berfungsi dalam ekosistem keusahawanan. Ekosistem ini merangkumi 9 fakulti yang disokong oleh institusi dan pusat kecemerlangan yang dilaksanakan dengan disiplin keusahawanan berasaskan inovasi. Pengurusan atasan universiti bersama dengan pekerja UMK di semua peringkat komited untuk merealisasikan UMK sebagai universiti awam Malaysia yang disegani kerana asas keusahawanannya. Dengan melaksanakan ekosistem ini, Institut Keusahawanan UMK, UMKEI, memayungi 3 pusat berasaskan keusahawanan lain. Pusat Pembangunan dan Pendidikan Keusahawanan CEED, Institut Perusahaan Kecil dan Sederhana ISMI, dan Pusat Penyelidikan dan Inovasi Keusahawanan Global GARIC. Fakulti Keusahawanan dan Perniagaan yang menerajui struktur ini telah berjaya mengembangkan jaringan keusahawanan kolaboratif seperti UMK Frontier Suite, Majlis Penasihat Keusahawanan, dan dengan bangganya mengetuai jawatan kuasa panduan KPT untuk pendidikan bersepadu keusahawanan. Dari aspek akademik, UMK menawarkan 29 program ijazah sarjana muda dan 16 program pasca siswazah dalam bidang perniagaan dan pengurusan, pelancongan dan hospitality, sains dan teknologi, serta seni dan warisan. Universiti ini sentiasa meningkatkan sistem pengajaran dan pembelajarannya untuk memastikan bahawa proses pembelajaran berlaku secara kreatif dan inovatif melalui My Academic Integrated System, My Eyes, Massive Open Online Course, MOOCs, dan pembelajaran teradun. UMK committed untuk mengembangkan graduan minda kelas pertama untuk menjadi peneraju industri. Bekerjasama dengan sektor korporat tempatan bertaraf dunia serta rangkaian institusi pendidikan serantau yang terkenal bertujuan memperkasakan UMK dari pelbagai sudut. Ini dapat dibuktikan dengan peningkatan kebolehpasaran graduan dan graduan yang mencipta pekerjaan melalui perniagaan. Penyelidikan, inovasi dan pengkomersialan adalah satu aspek UMK yang penting. Pembiayaan penyelidikan dan jumlah inovasi dan produk yang dikomersialkan meningkat setiap tahun. UMK telah menunjukkan prestasi yang baik dalam pelbagai pertandingan berprestij. Dengan hashtag UMK for Society, UMK juga terlibat dalam pelbagai aktiviti kemasyarakatan. Kaki tangan dan pelajar kami secara konsisten menunjukkan kemahiran dan kebolehan yang luar biasa. Dengan semangat kerja berpasukan yang begitu hebat, UMK tidak lagi menoleh ke belakang untuk muncul sebagai entiti pendidikan yang disegani di rantau ini. Kami di UMK percaya bahawa kehadiran kami akan memberi gambaran baharu kepada perkembangan lembah ilmu. Sesungguhnya teras kami, keusahawanan, akan sentiasa menjadikan Universiti Malaysia Kelantan relevan, unik dan berbeza.
Okay, Assalamualaikum and good morning everyone. Welcome to our webinar, Building a Career as a Data Scientist. As we all know, data scientist is one of the fastest growing and in-demand fields in today's job market. A career as a data scientist offers a wide range of opportunities to work on exciting projects, solving complex problems and making an impact in different industries. And today we are lucky because today we have Dr. Nicole Chong, who is a data scientist from Intel. Okay, she has 4 years experience as a data scientist, and what's interesting is she also have a PhD in statistics from Universiti Sains Malaysia, graduated on time with scale 1 without correction, I would say. So it's our my pleasure, okay, to introduce our guest of the day, which is Dr. Nicole. Uh, and she will be sharing a valuable insight and perspective on the topic related to data science. And I'm sure all of you will find her presentation to be informative and engaging. If you have any questions related to data scientists especially, or if even though you are coming from different field, but you're thinking of pursuing become a data scientist, you can drop your question in the comments, and I'll address your comments, I'll address your questions to Dr. Nicole. And without further ado, please join me in welcoming Dr. Nicole. Yes, Dr. Nicole, the stage is yours.
Yeah, thanks, Dr. Fokita, for the intro. So before starting with the presentation, I'll just talk briefly about my path in becoming a data scientist. So like Dr. Fokita mentioned just now, my education background is in statistics. I did my degree, master's, and PhD in statistics. Then right after graduation, I started working as a data scientist in the semiconductor industry. So even though my background is in statistics, but I haven't actually worked as a statistician before, but I do get to apply my knowledge in statistics when I work as a data scientist. So I've been working as a data scientist for almost 4 years, and I really enjoy it so far. So the reason why I chose data scientist as a career is because I enjoy working with data and using my knowledge and skills to build solutions that help solve business problems. So it's also never a boring job. So which is why I actually chose this data scientist path as my career. So okay, so let's get started with the presentation. So as a disclaimer, the sharing is based on my experience as a data scientist and also to the best of my knowledge. And the sharing is informative, not meant to promote any solutions. And the references are provided for information reference from others. So today for this presentation, I will be talking about the data science demand, data science careers, and what is a data scientist tasks and core skills, as well as the future of data science and the motivation to become a data scientist. So based on a study by Malaysian Digital Economy Corp, also known as MDEC, they forecasted that Malaysia's big data analytics market will reach a value of USD 1.9 billion by 2025. So it's expected that there will be more investment flow in data and analytics, and the demand for data professionals is expected to continue growing as companies seek to gain insights from their data. So as long as there is data, data professionals will be needed to transform the raw data into actionable insights so that business can understand their customers and also grow their business. Then data science is a rapidly growing field that is becoming increasingly important in many industries. So be it manufacturing, banking, telecommunication, aviation, and there are many more industries that data science is rapidly growing in. And this brings value to various organizations as well, be it like government, multinational companies, startups, or others. So as a data professional, we are able to enter many industries. It's not only restricted to only one industry. Then data scientists, they may also come from a variety of backgrounds. For example, computer science, statistics, mathematics, physics, engineering, economics, or some other background as well. And some data scientists, they may also have experience in a specific industry. For example, an individual from economics background and they have worked in the banking industry before, they may also transition into data scientist role. So there may be individuals who come from non-data science background and they did the degree in a different, not data science degree, then they pursue a master's or PhD in data science to start their career in data science. But regardless which background we are from, to be a good data scientist, we'll need certain technical and also non-technical skills. So these skills I will explain later on in the presentation in another few slides. These are some of the data science careers one can pursue. We can see that the data science careers, they have different roles and responsibilities, but there may be some overlap between them. For example, data scientists, the general role is to take data science projects from end to end, from data extraction to model development, then to deployment. So data scientists, they are mainly involved in cleaning and analyzing the data, designing and implementing models, and communicating the findings to stakeholders. So that's why the skills that they need are like programming skills, mathematics or statistics, and then they also need communication skills in order to communicate their findings. Then they usually use programs like either Python, R, or SQL. Then as for data engineer, they are responsible for the design, construction, and maintenance of the infrastructure and systems that store, process, and analyze large sets of data. So data engineer, they are involved in creating and maintaining data pipeline and ensuring that the data is accessible to other members of the organization, for example, to data scientists. Then they do need mathematics programming skill and big data skill. And usually they use programs like Python, Hadoop, or NoSQL. Then as for data analysts, another career as a data professional, they are involved in like figuring out how or why something happened. For example, in a company, if sales has dropped, then the data analyst, based on the data, they will have to figure out how or why something has happened. And from their analysis, the client will then use it to help make data-driven business decision. So their job may also involve querying data with SQL and analyze data using tools like Excel. And they may also be involved in creating dashboards using business intelligence software for data visualization, like Tableau or Power BI. And the difference between data analysts and data scientists is data analysts make sense out of the existing data, whereas a data scientist is more involved in data modeling to do predictive analysis. So this is just a general guideline on what the data professionals do. There may be some overlap in the responsibilities. For example, here we say that data analysts, they build dashboard for visualization, but data scientists may also be required to build a dashboard if there's a business need to visualize the data. So it's not only limited to data analysts, and there may be some overlap in the responsibilities. So the rest of the presentation, I'll focus more on data scientists, as today's webinar is about building career as a data scientist. So for the next slide onwards, I'll focus more on data scientists. Okay, so for this slide, I'll be talking about the data scientist task. Before starting any data science project, typically data scientists, we will have discussion with the domain expert to understand what is the problem statement, what is the objective of using data science, and we also discuss like what is the target accuracy that they want and other things as well. So domain expert is actually important in the data science project. So the domain expert is a person who has deep understanding of a specific field. For example, domain expert in healthcare may be the doctor who has knowledge about the healthcare data. So the role of the domain expert is to help the data scientist to understand the problem, the data, and also the business context. And after understanding the problem statement, usually the data scientist will identify like whether data science is needed to solve the problem, or maybe some statistical method is more appropriate compared to data science, because some cases the problem statement is simple, so using statistics is enough and also more straightforward. For example, if a simple descriptive analysis is needed for a problem, then a statistical method like getting the mean, median, standard deviation and comparing them is already sufficient. So if we determine that data science needs to be used, then the data scientist will have to identify like what data scientist technique is suitable, whether they want to use maybe machine learning or deep learning. And if you're using machine learning, whether the data probably have labels, then maybe we'll be using supervised learning. And if the data has no label, then the data scientist will use unsupervised learning. So all this we will determine beforehand. Then data scientists also usually have regular checkpoints or discussion with the domain expert. This to make sure that the solution that we build actually align with the requests of the domain expert. Because there is no use building a fancy solution if it doesn't help to solve the problem. So usually we will have like regular discussion to make sure that what we are building so far actually align with the request and actually can help to solve the problem statement. So if we see below, there is a flow chart. So this is the typical data science workflow, which is part of the data scientist task. So first is the data extraction and exploration. The data may be provided by data engineer, or data scientists may do the extraction. Then after we have the data, usually it will be followed by data exploration. So the data scientists will explore the raw data and identify the relationships between the different data variables using statistics. So basically the step of data exploration is to understand the data better so that we can plan later on how to clean the data in the next step. And data exploration usually it involves data visualization, like let's say using histogram, bar chart to compare the data, and also statistical techniques on the raw data. We may look at the mean, median, standard deviation of the variables. Then after exploring the data, the next step, which is an important step, is the data preparation or data cleaning step, where the data scientists will make the raw data as clean as possible. So for real data, unlike textbook data, real data is usually very noisy. So there may be a lot of noise in the data. For example, there may be duplicates, null values, or other sources of noise in the data. So the data scientists will have to determine what is the appropriate steps to clean the data, or we can experiment with different data cleaning steps. Then you can see which combination of the data cleaning step actually helps with the model performance. Then after cleaning the data, usually data scientists will then use feature selection algorithm on the data, this to reduce the number of input variables. So for real data, usually there may be hundreds of thousands of variables. So to reduce the computation time and also improve the performance of the model, only the important variables will be selected for model building by the feature selection algorithm. Then the last part is the model building and prediction. So usually during model building, we will also do some hyperparameter tuning to select the best hyperparameters, and we also try out various algorithms to see which gives the best model performance. Then once the model reaches the target accuracy that is set by the domain expert, then we will test the model using the latest data followed by deployment of the model. So what I've shown here is actually just a general data science workflow. So the data scientists may add in more steps to improve model accuracy if needed. For example, in real data, usually the data is quite imbalanced between the classes. So the data scientists may add in more steps like to address the class imbalance in the data. So there are many other things that can be added in this workflow depending on the data and also the accuracy that is needed. So this is a continuation of the data scientist task. Generally, we think of data scientists as building models and doing predictive analysis most of the time. But that's actually not what data scientists spend most of our time doing. So the pie chart here actually shows a survey on what data scientists spends most of the time doing. So if you're interested to know more about the survey, you can actually click the link below in this slide. So this survey shows that data scientists spends most of the time doing data preparation, cleaning the data, about 60% of the time. So real data is noisy and complex, so a lot of the time and effort is spent to make the data as clean as possible before moving to other steps like model building. So there's also this term that we call garbage in, garbage out. So this means that the quality of the data that we use will actually determine the result, our model accuracy. So if we input noisy data into the model, then we will expect that the prediction will not be so good. So which is why data scientists, we spend most of our time and effort in cleaning the data and only a few percentage of the time in doing other things like model building. Then in this slide, I will talk about the data scientist's core skills. So the data scientist's core skills can be divided into two. We need a combination of technical and non-technical skills. So this slide will cover the technical skills that are needed. So if you see the Venn diagram on the left, it shows that machine learning is an intersection of computer science or programming together with statistics. Then data science is an intersection of all three. So that means computer science, statistics, and also domain knowledge. So for programming, one of the skills that we need as a data scientist is computer science or programming. So programming, we need it in order to build data science solution. And the common programming languages used by data scientists are actually Python or R. So whether you use Python or R, this depends on the company that you're working in and also your industry. And some data scientists, they also use SQL for data extraction and interacting with databases. But this doesn't mean that you have to be an advanced programmer in order to be a data scientist, but you should at least know the basics of programming and able to build a solution. Then data scientists, we usually use open source library. For example, in Python, we use sklearn. So we use open source libraries a lot, and a lot of the code can actually be found online. But we will still need to understand the code and know like which part of the code to use and to edit them according to our use case. Then I think that programming is also something that gets better with more practice as we work on more projects. Then another important technical skill that is needed for data scientists is statistical knowledge. It doesn't mean that we will need to have advanced knowledge in statistics, like having a PhD in statistics to be a data scientist, but we will need to have the basics in statistics. This is because statistics is important when we analyze and obtain insights from data. For example, if we want to compare like the distribution of two data sets, then we will need the statistical knowledge to know like which test should we use to compare two distributions. And having statistical knowledge also helps us to better understand how the machine learning algorithms that we use actually work behind. So having that will actually improve our understanding of the algorithms that we use. Instead of just applying it directly only, we will also understand like how it works. Then other than that, domain knowledge is also very important. So domain knowledge is actually the general background knowledge of the field that we apply data science in. For example, if you're working as a data scientist in the banking industry, then the domain knowledge that you will need to know is the general background in banking. So domain knowledge is important because we will need it to understand the business problem and the goals. So before we build a solution to solve a problem, we'll first need to understand what is the problem that we want to solve. And having domain knowledge will help us to understand the problem statement better and also understand what's the impact of the data science solution that we built in solving the business problem. So learning about domain knowledge, it usually comes after we have entered the company, but some data scientists with existing background in certain industry may already have some domain knowledge. For example, some data scientists that have worked in the banking industry before, they already have some domain knowledge on the banking industry. But then if we are fresh graduates or we do not have, or we are new to the industry and we don't have the domain knowledge on the industry, then when we enter the company, when we work on the data science project, we can actually engage with the domain expert that we are working with by asking them more questions about the project to understand the domain better. And there are some companies that have basic trainings also on the domain side, so we can actually attend those to improve our domain knowledge. So other than these three skills, data scientists, we should also have knowledge of machine learning techniques that are necessary for building predictive models. And it's also good to have knowledge of deep learning methods, because for some data sets, deep learning methods may be needed. Then these are the main technical skills that are needed by data scientists. But other skills like building data visualization dashboard to get a high-level view of data, and also cloud computing to scale data processing. This may also be needed for a data scientist, depending on your role as a data scientist in the company, and also what is the industry that you are in. Because some roles may require you to build dashboard and also to use cloud computing as well. So if your role requires you to use those, then you will also need to know those skills. So just now I have covered the technical skills. So in this slide, I will talk about the non-technical skills that are required from a data scientist. So data scientists, we actually do interact often with others as well. So communication is one of the most important skills to have for data scientists, or to be exact, effective communication skills. This because we will need to communicate our findings and recommendations to colleagues which may not be from the data science background. It could be your customers, your management, higher management, or it could be the domain expert. So they are not from data science background, so they may not be so clear when we communicate our findings. So we need to work on the effective communication so that we can help to turn our findings and recommendations into actionable insights, and also help the management with data-driven decision-making. So for effective communication, usually we will have some kind of data visualization, like maybe a pie chart or bar chart. So this makes it easier to visualize the high-level overview of the data. Then for other than communication, we also require problem-solving skills and the ability to search for resources to help with problem solving. This is because for data science problem, there is no one template to solve every data science problem. So the path to solving a business problem, it may also change with every new data set. And the problem solving skills that we have will help us to overcome the challenges that we face to solve the problem. And also the problem that we are facing, maybe in our project, most probably someone else has come across a similar problem before. So the ability to search for resources to help with the problem solving is also important. Be it like maybe Google search, reading a paper or book, or it could be many more resources. But the ability to search for those resources that we need is also important as a data scientist. Then the third non-technical skill that is needed is continuous learning and improvement. So even after becoming a data scientist, there is also a need for continuous learning to continue grow as a data scientist. Because data science is a wide and quickly evolving field, so continuous learning will benefit our career greatly as we will have a broader range of skills and we also understand our subject matter better. And nowadays, there are many resources for learning and improvement. It can be paid resources like online learning platforms, for example, Udemy, Coursera. It could also be non-paid resources like watching data science YouTube videos or reading about maybe data science articles online. So there are actually many resources for us to learn from. Maybe just need to find the time to learn. So other than learning, like just learning from like online learning platforms, it is also good to work on data science projects. For example, you may find projects from Kaggle, and so it is good to actually work on the projects and get our hands dirty. Actually try working on some projects instead of just enrolling for online courses. Then other than that, teamwork is also important for data scientists because usually for data scientists, we don't work individually. We usually work in a team because data science project usually it requires multiple data scientists and we also need to work with the domain experts. So we are working in a team, not as an individual. So the ability to work with others and having good teamwork is also important for the success of a data science project. Then next, I will also talk about the future of data science. So this is on the prediction of the future of data science in this article by Forbes. So if you're interested to learn more about it, you can actually click the link that is below in the slide. So in this article, it's mentioned that low-code or no-code data science platforms that provide those drag and drop interfaces will become even more popular in the future. So this platform, they actually help improve data scientist productivity because it will automate some of the data scientist work. But data scientists will also still be needed to oversee and interpret the results. And by having all this automation, so data scientists will have more time to focus on other things like analysis of the data and also the results. And using this low-code or no-code platform, the data scientists can also easily share and collaborate on the projects with other members of the organization. So this helps to improve collaboration. So usually we work in a team. So using this kind of platform will help to improve collaboration within the team. However, for this kind of platform, even though it's low code or no code, but behind the platform, data scientists will still be required to maintain the platform. So an example of this kind of platform is Data IQ. They provide a visual interface for automation. Then this low code or no code platform also make data science more accessible, not only to data scientists, but also it will help the non-technical users because it allows those non-technical or non-data science users to perform data analysis and also build models without using extensive programming knowledge. Then Forbes also predict that there will be an increasing prevalence of cloud computing. So example of cloud computing could be like AWS, Google Cloud, Microsoft Azure, and many more. So these companies, more companies are moving towards the cloud. So there will be an increasing prevalence of cloud computing and data scientists will also be required to learn up more about cloud computing. So cloud computing, what it does is it actually provides data scientists with access to powerful computing resources to process large data set. So as more companies move towards the cloud, then data scientists in the future will need to be more familiar with those cloud-based data processing tool and technique. So this is actually the last slide of the presentation, which is on the motivation to be a data scientist. So the first motivation to be a data scientist is because there is a high demand for data scientists. So data science is a rapidly growing field, and there is a high demand for data scientists with the necessary skills and experience. Then data scientists typically also have high earning potential, and the salary range for data scientists can vary greatly depending on your company, your industry, location, and also what is your specific role. And another reason to be a data scientist is because um, there's actually a variety of industries that you can enter, because data science can be applied to a wide range of industries. So that means data scientists have a lot of options when it comes to choosing where to work and what type of work to do. So for example, you may be interested in the banking industry, or then maybe later on you may decide that you may want to try maybe the semiconductor industry and so on. So there are many industries that a data scientist can choose from. Then data science is also about using data to solve real world problems. So this can be very rewarding, especially when the solution that we build have a real impact on the organization. For example, maybe the solution that you built has helped your company to save like maybe millions of dollars. So it's actually a very rewarding role. You can have this satisfaction that what you built has actually helped others, maybe in making, in automating something, or you have helped to reduce the time needed for something. So you can actually see the impact of what you have built. So it is a rewarding role. Then another reason is data science is a field that is constantly evolving. So there are new techniques and technologies emerging all the time. For example, we have the AI chatbot, ChatGPT. So previously we didn't have ChatGPT, but then now we see that it is mentioned almost everywhere. So this means that data scientists need to be lifelong learners. So this can be exciting, and also it's never monotonous, never boring. So if you're someone who finds joy in learning new things, so data scientist will be a suitable role for you. So as I understand that in this webinar, the audience are mostly students. So I will also talk about how maybe a fresh graduate or someone who is just about to enter the industry can improve the chances in landing a data scientist role. So we will need a relevant skills and also relevant experience. So relevant skills, we can see from the previous slides that having the core skills are actually important, like having skills in programming, statistics, and also machine learning and probably deep learning is important. Then relevant experience is also important, but as a fresh graduate, because we haven't actually worked, so to get the relevant experience, fresh graduates can do that through internship. Also on internship, you'll get the opportunity to work on real data and also see how it's different when you apply on data science on real data compared to on textbook data. So one thing that I found is different is when I actually started applying data science on real data, I found that it's actually more challenging compared to when I applied data science on textbook data, because real data is usually very noisy and a lot of steps are needed to make the data as clean as possible. So if you actually go through an internship and you get an opportunity to work on real data, it will be good. Then another thing that is good for fresh grads to have is probably a data science portfolio, so that you can actually showcase your skills and knowledge in solving a data science problem to the employer. So for example, if your data science portfolio showcases that you are able to solve a data science problem maybe using natural language processing, NLP, and your employer is looking for data scientists with experience in NLP, then if you can showcase that in your portfolio, then you will get a better chance of getting hired. So that is the importance of having a data science portfolio, that is to showcase your skills and knowledge to a future employer. Then other than that, it's also good to join maybe data science competition if you can, because it can help to expand your knowledge and also your experience. So that is all from my side for today. Hope the sharing has been beneficial to the audience.
Okay, okay, thank you, Dr. Nicole. I think I have, the audience have one question from, I think, Dr. Jafri. Jafri Nasi. So he asked, dear Dr. Nicole, for non-computer statistician or non-computer scientist, are there more accessible pathway or trainings to become a certified data scientist?
So one way right now is some people that maybe they come from non-computer science or non-statistics role. So what they do is they will take masters or PhD in data science. So I've seen some data scientists that are doing that. Then there are also some of them that are taking certifications outside as well, other than taking masters or PhD. But other than that, if you do not want to go through like the official route, like taking certifications or masters or PhD, there's also another way where you can. What I've seen some other data scientists that are doing is they actually have the data science portfolio. So maybe their degree is maybe in physics, and they have no experience in data science, and they also do not have maybe higher education in data science. But what they do is they have a data science portfolio that actually showcase them actually solving the problems in data science. So even having those data science portfolio itself will also help improve the chances of getting hired. It doesn't mean that we will need to go through the official route, like taking higher education or certification. We can also take like online courses and also having a data science portfolio. But I don't think that having data science portfolio is probably more important than only going for online courses, because online courses, anyone can actually go through those online courses. But then for data science portfolio, we actually need some skills and knowledge and application of the data science knowledge to actually solve those problems. Yeah.
Okay. One more question also from Jafri Nasi. How new and popular is the low-code or no-code data science platform?
Right now, it's getting more popular. So far, I haven't actually used it yet in any of my. I haven't actually used it right now in my job. But then I do see that there's a lot of people that is turning up about the low-code or no-code platform, and it's predicted that in the future it will get more popular because we want to automate some of the job of the data scientists. Because right now, data scientists, we actually spend, like I mentioned just now, most of the time on the data prep. So having this low-code or no-code platform, we can actually design our pipeline, the data science pipeline, according to the steps that we want. We can just drag and drop instead of writing the code. So it actually helps to save a lot of time for data scientists. And there may be those people from the non-data science background that may want to adopt this. So because this low-code or no-code platform, they enable people to build data science solution without much knowledge in programming. So those with non-data science background, they can actually still utilize them in their job. So maybe someone who is just starting out as a data scientist, maybe not so much background in data science yet, they can actually explore with these tools. So it is expected that in the future, I mean, based on the article by Forbes, that we will have more of these platforms. Actually, right now, we already do have these platforms, just that it depends on the company whether they want to start using these platforms or not.
I see. Okay. One last question from Jafri Nasir also. What software are frequently used by data scientists in companies, especially in Malaysia? I believe there's been some debate. Some company they use
Yeah.
this kind of software. Some company they are using this kind of software. So maybe from your perspective, I mean, what are the software that are frequently used by the data scientists, especially those in Malaysia?
Mm. Yeah, actually, data scientists, we usually use Python or R in Malaysia as well. So I've also used R and Python before, and I understand that there's a debate on which one is better, like R is
Yes.
better or Python is better. But actually, this depends on the company that you're entering in. Let's say if the company that you enter, they prefer Python, and maybe the infrastructure, they already have some existing infrastructure that is written in Python, then they will tend to prefer to use Python so that we can have easier collaboration with others. Whereas maybe if the company that you enter, if you are using R, like maybe all the infrastructure, model deployment, everything is written in R, then most probably you will also need to use R. But usually either Python or R is used, so it's best to have like maybe some knowledge on both of them. But right now, I do see, from my experience, I do see that Python is used more often compared to R. But this is just in general, based on my experience. So it may not apply to all. So it's better to have knowledge in both, either one. Yeah.
I see. Okay. I have one question which is coming from me myself. Okay. Since data scientist, I mean, like, is kind of famous, and then regardless which background you are coming from, either from engineering, economics, or others. So from the computer science student punya perspective lah. So what will be the unique selling point? I mean, if you're taking computer science, if you're taking information technology or statistics, so uh how to say it? Macam
You mean
uh,
what's the advantage to be a data
yes,
scientist if you're from the computer science background?
yes, those are related with
Yeah.
the data scientists. Yeah.
Yeah, so I feel that for data scientists from computer science background, what their advantage that they have over other data scientists from other backgrounds is they tend to have like very good programming skills. So they are able to build solutions faster, and also probably they can do a lot of automation as well because automation requires usually more advanced programming skills. So what I've seen from data scientists from computer science background is they are quicker in building solutions, and also they tend to they are able to automate most of their work. So I think yeah, so then they can also help to build like infrastructure, maybe data infrastructure and all that, using their extensive knowledge in programming. Then other than that, they can also, they are able to write good code, like good and clean code. So those data scientists from computer science background, I think that their advanced knowledge in programming actually gives them a competitive advantage as well over others. So I think each background actually have their own advantage. For example, this is from computer science background point of view. Then maybe from statistics background point of view, we see is that data scientists purely with statistics background is we are able to determine like which statistical test is better in analyzing data, and also we can analyze the results. Then we can know like which test to use correctly and all that. So we actually do complement each other because data scientists we usually work in the team. So each data scientist may have their own advantage. So when we work together, we actually complement each other. So that's what I see usually when we work inside the team. Yeah. So that's why some data scientists we usually don't work alone. So each data scientist we actually have like something to offer in the team. Yeah.
No,
I hope
okay,
that
thanks.
answers your question.
Yeah, it's really answered my question. So actually, I mean, for sure, since I mean, data scientists, I mean, can be coming from different background. So for those who already pursue or in the field of computer science or statistician, they kind of like afraid because data scientists can come from engineering, can come from those who are not other type of science aside from computer science and statistics. So when we see from the good perspective, so maybe because these students that have been exposed to coding, so they know how can do they do the automation, they write a good code, and then
Yeah.
the interesting point I can get from your session is basically you don't work alone, you work with a team. So basically the solution
Yeah.
is not coming from you only, it's basically coming from the team, is it?
Yeah, so each data scientist we can provide an insight. Like let's say, each data scientist we have our own something to offer. So maybe each of us also we can like let's say in a project we can actually each data scientist can actually recommend like, let's say another way to solve this problem. Maybe person A may think that I want to solve this problem using this way may be good. Then another person may think that how about trying out this way? So each of us we can try out different methods and we can also see like which method is the best to solve the problem later on. So there's a lot of discussion going on. So maybe data scientists we can usually what we do is we will work separately on different methods. Then after that we will have like a group discussion. Then we will discuss like let's say this technique that I've tried, how has it performed, and another person may actually give the inputs. And maybe sometimes if one data scientist is having problem, let's say they have problem analyzing the results or understanding some things, then another data scientist may also chip in and help to unblock them. So when we work together, we actually put forward what we are good at. For example, one data scientist who has statistics background, another one with computer science background. So the computer science one can help the statistics one maybe with the coding, like give some inputs about the coding, let's say when there's a bug in the program. Then the one from statistics background can also provide input, let's say in the results analysis, like how to analyze the results better, maybe using statistical methods and all that. So we actually do complement each other and we can also try out different methods so that we can actually collaborate and probably finish up the project faster when we work together instead of working sideways. Yeah.
Okay, I think that's it from me and also from the audience. I didn't see any more questions. So I would like to thank you, Dr. Nicole, for being with us today. And thank you all the audience for joining us today on the webinar of building a career as a data scientist. Okay, even though the term is career, but I hope you get informative insight, valuable insight to actually for those, especially for those who are students, who never know about what is a data scientist. I hope you get some insight what is a data scientist and how you can build your path to become a data scientist. And once again, thank you, Dr. Nicole, and thank you all the audience for participating in this webinar and showing the interest in this topic for today. And we look forward to having you to join us again in our future webinar and events. Happy Chinese New Year and have a great day ahead. Thank you, Dr. Nicole. Thank you, audience.
Yeah,
Okay, that's all.
thank you, Dr.
Thank
Fakita.
you.
Yeah, thanks
Okay,
everyone.
thank you. Assalamualaikum.